Hello friends, in this presentation we are going to discuss about it states that any two terminal of a network can be replaced by an equivalent voltage source and an equivalent series resistance. The voltage source is the voltage across the two terminals with load, if any, removed. The series resistance is the resistance of a network measured between the two terminals with load removed, and the constant voltage source being replaced by its internal resistance, and constant current source replaced by an infinite resistance. So the complete network can be replaced by VTH and RTH. So steps to be followed in the Thevenin's theorem solving. First step is to remove the load resistance RL. Next step, find the open circuit voltage VTH across the point A and B. Third step, find the resistance RTH as seen from the point A and B. Step 4, replace the network by the voltage source VTH in series with resistance RTH. Then step 5, find the current through load resistance RL using Ohm's law. We will see some practice numerical based on this theorem. So assuming this network, example is given that the find Thevenin's equivalent network across terminal A and B. So our first step is to calculate the VTH. This terminal A and B, voltage across this terminal is Vx. This Vx is nothing but your Thevenin's voltage VTH. So in this case Vx is equal to VTH, and the dependent current source having an value of 0.1 Vx is belongs to mesh 1. Assuming I1 current is flowing in the mesh, so this current I1 is minus 0.1 Vx, as the direction of this current is opposite to the current source. Next step, now writing the KVL VTH equation. So we will start from B point and we will end at point A. So between this point B and A, 4 volt battery is coming, 2 ohm resistor is coming, 3 ohm resistor is coming, and then back to VTH. So 4 minus 2 I1, since 3 ohm is in the open circuit, so current flowing through that resistor is 0. So that's why that value is not representing in this equation, and then directly minus Vx. We know that I1 is minus 0.1 Vx. So substitute the value of I1 and then find the value of Vx. Vx is nothing but the VTH, that is 5 volt. Step 2. Now we will calculate the Norton's current. So to calculate the Norton's current, now you short circuit the terminal A and B and mark the current IN. The dependent source 0.1 Vx depends on the control variable, which is Vx. Vx is across the point A and B, and there is a short circuit. So voltage across any short circuit is 0. Therefore the value of Vx is 0, and hence the value of 0.1 Vx is also 0. So according to Ohm's law, Norton's current is V by R and it is 0.8 ampere. Step 3 is the calculation of RTH. In this case, RTH is VTH by Norton's current. As previously we have calculated VTH and IN, substitute these values, we will get the value of RTH. And the final step, that is Thevenin's equivalent network with VTH, RTH and terminal A and B. The numerical, find the Thevenin's equivalent network again across the terminal A and B. So first step is to calculate the VTH. Now mark the location of VTH across the terminal A and B. Now you apply the KVL to the mesh. So the KVL equation is will starts from B and ends at A. So it is plus 5 minus 10I1 minus 10I1 is equal to 0. So I1 is 0.25 ampere. Now writing the VTH equation, that is 5 minus 10I1 plus 8I1. Current flowing through 1 ohm is 0. So it is represented by 0, then minus VTH. Substitute the values, you will get the value of VTH as 4. Now next step is to calculate the Norton's current. So apply KVL to mesh 1 and mesh 2. You will get the two equations. Solve these two equations simultaneously. Then you will get the value of Norton's current. Step 3 is to calculate RTH. We know that RTH is VTH by IN. Simply substitute the value of VTH and IN. Then step 4 is Thevenin's equivalent network. These are, thank you.